Discuss the two methods of chemical combinations. Okay, the first one is electrovalent combinations, and the second one is this electrovalent combination. The second one is covalent combinations. Okay, so I'm going to start with electrovalent combinations. All right, we'll talk about the covalent combinations later in this video. In the electrovalent combinations, there is transfer of electron from one atom, which is usually the metal, to another atom that is usually the non-metal. So the electrons for this donation are the electrons that are on the outermost part, the outermost shell, or the outermost orbit of the particular element that is involved in the reaction, and those electrons are known as valence electrons. Okay, they are known as valence electrons. V-A-L-E-N-C-E. I'm sorry, I meant valence electrons. Okay, so valence electrons are electrons that are available for chemical reaction, simply put. Okay, so let's look at an element such as sodium. Okay, it has electronic configuration of 1s2, 2s2, 2p6, and 1s1. So sodium in the outermost shell, this occupies the outermost shell. Okay, so sodium can easily give out one electron. Okay, so it can easily give out one electron, and so that makes it quite reactive. So it needs less energy to give out one electron. Then let's look at non-metal like chlorine that has 1s2, 2s2, 2p6, right, and 3s2, and ends with 3p5. So we're looking at the outermost electron. This is the outermost. Okay, all it needs is just one electron so that this becomes 3p6. And if this is this becomes 3p6. If this is 3p6, it will become more stable for it. Okay, it will become a more stable element. I'm sorry. Okay, it becomes a more stable element. So what happens? So you can see that sodium and chlorine will easily react. Sodium can easily give this electron to chlorine. Okay, now if sodium gives out this electron to chlorine, this will become the configuration, the electronic configuration of this sodium in this combination, in this compound sodium chloride, and why this will become the new configuration for chlorine. So this will become 3p, this 3p6 for chlorine. Okay, now you're wondering, okay, if sodium gives out an electron, it attains the electronic configuration becomes like that of neon. Does that make sodium neon? No. What confers the character of an element is the proton number, the number of protons it has. That's the atomic number, okay, and not the number of electrons. So even if sodium gives out this electron, sodium will still behave like sodium because sodium will still have 11 protons left. So let's quickly look at how this reaction would occur. Let's look at how it will occur. So I'm going to erase this quickly. All right, so here we go. We have sodium. Is sodium here. So this is the outermost shell of sodium containing one electron, right? Then there's chlorine. Okay, has 1, 2 electron, 3, 4 electron, right? 5, 6, and then 1, and it needs only 1 to achieve a stable state. Okay, it should achieve stability. So this sodium, this chlorine, so sodium will donate this. So our new element, our new compound will look this way. The outermost shell of sodium. So we have 1, 2, 3, 4, 5, 6, 7, 8. While that of chlorine too, the outermost share after receiving this one will now be the same like that of sodium. Okay, then we have this 8. Okay, why this one now will become this, our sodium will become 1s to 2s to 2p6. Okay, like I told you, even if it has the electronic configuration of neon, it does not make it behave like neon. Let's look at another example quickly. Here we go. All right, here we go. On this example, let's look at magnesium and chlorine. How do they combine? Magnesium and chlorine. Then we have chlorine. Okay, magnesium has 1s2, 2s2, 2p6, and 3s2. Okay, while chlorine has this, chlorine we have, like I mentioned before, so the outermost part of chlorine will be 3s2 and 3p5. That was almost with the configuration of neon plus 3s2 and 3p5. Okay, so sodium needs one electron to achieve a stable state, but magnesium has 2. Okay, so in this equation there we need two atoms of chlorine to react with magnesium so that they can accept these 2 from magnesium, 2 electron, and share it, one here and another one for another chlorine atom. So what will happen is our MgCl plus Cl, okay, this will be Cl2, will give us Mg, that's magnesium, 2 plus is giving out 2 electrons, so it becomes positively charged, and chlorine, the 2 atoms of chlorine are accepting electrons, so they become negatively charged. Now if you look at the diagram, let's see, this is the outermost part, this is 0, 2 electrons. Okay, so we need this one chlorine, this another chlorine, okay, with 1, 2, 3, 4, 5, 6, and 7. Then this one too has the same, 2, 3, 4, okay, 7. So this our magnesium, this chlorine, this our magnesium will give 1 to this, okay, and also give 1 to this. Okay, it's that simple. All right, I hope you understand this. So let's quickly look at the next method, that's the covalent bonds. Okay, how electrons are shared in covalent bonds. So let me use a new layer. All right, covalent bonds, so we're looking at covalent bonds. Okay, in covalent bonds, example is hydrogen plus hydrogen. Okay, here we have hydrogen is what, 1s1, right? It just has 1 electron. So what happens is we have this hydrogen with 1 electron, and then we have another hydrogen with 1 electron. So when they react, if there's a covalent bond between them, what happens is the electrons are shared and not donated. Please take note, the electrons are shared but not donated. So this one brings 1 here, and then this one brings 1 here. Okay, so these electrons will revolve around, and this one will revolve around this. Okay, another example is chlorine, Cl2. Okay, we have 1 has 0 electrons, calling it 0, not so electrons. Okay, so 7 here. Then we have another chlorine, donates 7. So we go, and then we have 1, 2, 3, 4, 5, 6. So 7. When they meet, when they react to form, this donates this electron and this donates this electron. Okay, so what we'll have, it will be this how they will react, or this how the electrons will attach to each other, to the other element. So this the other chlorine will now donate one of the electrons. Let's say this, that's one of the electrons. Then it still has its other 6 electrons in the outermost orbit. So this electron, now this is sharing, this one here, this chlorine is sharing electron with this, and this is also sharing electron with this. Okay, so that's what happens in covalent bonds, covalent bonding, or covalent chemical combinations. Other examples that you might want to try out yourself is ammonia. Okay, there are covalent bonds here. Water, covalent bonds. Methane, covalent bonds too. These are also example of compounds that the various elements are linked by covalent bonds.